And next up, we have a teammate of mine, Anthony Shaw, who is going to talk about something absolutely terrifying. Tell us more about that, Anthony.
Okay, hey everybody. Yes, my name is Anthony Shaw, and I'm talking to you today from Sydney, Australia. Before we start, I wanted to give some acknowledgement to the traditional custodians of the land on which I'm presenting, which is the Darkinjung people, and pay my respects to elders past, present, and emerging. So we're going to talk about Postgres security. I'm a cloud advocate at Microsoft, and over the last year, I've been playing around with Postgres, trying to see different ways of trying to attack my own Postgres infrastructure and test it out to make it more secure, and then seeing how I can summarize those tips into things that our customers can do and users of Postgres can do. So I'm a cloud advocate at Microsoft. I focus almost entirely on Python, but I get pulled into lots of other things like Postgres, for example. I'm also a fellow of the Python Software Foundation. I contribute to a lot of open source projects, including Python itself, and create open source projects and publish those. My links are at the end of the talk. I also like to break things mostly on purpose, and regardless of whether I'm working in a big company like Microsoft or one I've been working in startups, I like to try and break into internal infrastructure, which is normally to discover things which need fixing and then tell people why they need fixing and where. So part of that is looking at security issues, and part of that is also looking at processes and just the way we address things. Like I say, Postgres has been an area of interest of mine. So this kind of comes back to how you think about network security in Postgres. So if you think about Postgres itself, it's just a traditional model of the PSQL client. So that could be the command line, that could be an application. It's communicating over the network somehow, and it's talking to the Postgres server. So in a traditional application environment, you've got an app that has a database. It communicates over a virtual network, and then it talks to a Postgres server. That can also be another model where you have somebody who's developing a DBA or somebody who's actually programming the database needs to connect to the same server. So you've got an application that's connecting to your app. Your application is connecting to the database, and then you've also got a developer that's maybe connecting to the same database to run some queries, or a DBA connecting to the database. Part of the challenge here is that you essentially have Postgres as a server exposed on the network, and then by default, you can expose the data inside that database to people who shouldn't be having access to it. So I'm going to walk you through some scenarios. So for example, if you were to connect to a Postgres database and you connected to the server by the host name, you gave a username of web and a password of webadmin123. Postgres has got host-based access control in the Postgres configuration. So it would look at the IP address that it's connecting from. So where's this coming from? By default, Postgres has a any policy with no password, as I'm sure many of you know. So if you deploy the Docker image or just install Postgres, it will let anybody connect with no password, which is not ideal. So what typically people do is introduce password control and then put some sort of host control policy in. The host control policy will then look at the source IP address, and then it will look at the username and password that have been used to connect. So this will then go through to a different part of Postgres that looks at the username, the password that was used, and the database that was requested. If all of those match, then access is granted. So at the protocol level, what's happening in Postgres is the client is sending a series of messages to the Postgres server, each time saying, okay, can I connect? Can I connect using TLS SSL? In which case, yes, it would then send a request saying, okay, can I connect with this username, this password to this database? And then Postgres would come back and say, yes, you can. Once that has been confirmed, then the client, whether that is an application or a DBA console, or you're using PSQL on the command line, would then give you the ability to query data and look at the database. So this is the kind of area that I've been focused on, which is, okay, so if an attacker is looking at this and they want to gain access to a database, what can they do to make that happen? So in a different scenario, if you tried to connect and the source address was still okay, so let's say you had any host allowed, but the password was wrong, then what will happen is Postgres won't match the username or password, and it will reply back with an error code 28P01. This is important because what I discovered when doing some testing is that in the protocol and basically in the error codes, Postgres will respond with different error codes depending on what the authentication issue was. So ideally, in an authentication scenario, if the request was invalid because either the IP doesn't match one of the hosts, or the user or the password was wrong, or the database was invalid, then the server should come back with a generic message. You don't want to give away any information to the attacker. Now, Postgres has been designed with developers in mind, and it's more about usability. So it uses a descriptive error message to say, okay, here's what you've done wrong. If you exposed Postgres over the network to an attacker can use this information, and I'll show you in this talk how that can work. So that's the first error message we can get, which tells us that the password was invalid. Now, so far, all I've managed to do is guess that there's probably a user called web and a database called web. And the password, I can just type in any old junk, and I can immediately get a response back saying, okay, you do have access, but the password that you used is not correct. If the source address is wrong, so if you've got better control in the host-based access, so if you haven't just allowed any IP address to connect, and somebody tries to connect to the server over port 5432 from a machine that isn't allowed, they will get a different error message that says that the host is not in pghba.conf, which is the access control configuration file. This is what comes back at a protocol level. So it's a different number and it's a different error message. So what I discovered when scanning Postgres servers that have been configured in different ways is that I can detect whether or not it's in the host-based access control or whether it's the username and password failure. It's not that difficult to spoof IP addresses in some networks. So you shouldn't rely on host-based access control in this way. And I'll talk a bit towards the end about other things you need to consider. Okay, so in another situation, if you have the source address is correct, the user is incorrect, and the password is incorrect. In older versions of Postgres, I believe it's 12 and below. I can double check that and post the notes later. If the username is invalid, you get a different error code to when the password is invalid. The reason this is important is because what you can do is for older Postgres versions, you can enumerate the usernames until you get one that's likely to work. And then once you've got a working username, you can sit and attack basically using different passwords. This is called a password spray. So it's just like a dictionary attack on the endpoint. But with other network protocols like SSH, for example, or remote desktop, if the username is invalid or the password is invalid, you get the same error message. With older versions of Postgres, you'll get a different error message if the username is invalid as opposed to the password. It's a lot easier to guess usernames than it is to guess passwords, because usernames typically fall into a fairly small set, which is what I'll talk about. So if you go back to, can I use these techniques to try and figure out what the login is to your Postgres server? There's three things that I need. One is a database name, one is the username, and then thirdly, the password. So if we think about the database name, then there are definitely ways that we can guess what that could be. And there's a list of common database names depending on the application. So if I'm an attacker, then I know what kind of server I'm attacking, and I can probably try and guess the database name, or I can come up with a list, and I can enumerate pretty quickly over that list. In terms of usernames, in the tool that I've put together, which I'll demo to you in a minute, had a look at what common usernames are the most frequently occurring ones. The username Postgres obviously would be right up there. PGA, DBA, admin, and administrator, most commonly configured usernames in Postgres. And then there's also application-specific usernames as well. So web frameworks or like applications that are being used. And then the last thing I need is a password. So like I said before, depending on which bit I got wrong, I'll get a different error message in older versions of Postgres. I get 2800 response if the database name or the username is invalid. And then if the password is invalid, I get 28P01. In newer versions of Postgres, I tested in 14 earlier, you get 28P01 if the username or the password is invalid, which is a big step up from the older versions. So when it comes to trying to guess the database name and the username, what you would probably do if you were an attacker is you'd look at the application that you're trying to hack into and look at, okay, can I figure out what web framework it is? Can I figure out what kind of application it is? And then based on that, can I come up with a word list of things that it could be? And then once you've got that, you can guess possible database and username combinations. So for example, it could be the username web with the database web. If it's a blog, it could be the username web and the database blog, etc. So WordPress would be another common application that's been deployed. So next step is I need to come up with some passwords. So what I would do as an attacker is I would try all the easy ones first, which is the most commonly used passwords. And I'll show you a list where that comes from, to come up with some easy passwords and try those. Then I'd go down to another list that I've put together as about 6,000 harder passwords, but also quite predictable. And then if that didn't work, then I'd put together a custom password list, which I'll show you how to do as well, which could range from a few thousand to tens of thousands of passwords. So, if it's a poorly configured application and it's got a username of web and a password of web, then it won't take very long to connect into that app. So when I was doing this research, instead of doing this all using clients and stuff, I decided to write a tool to automate this. Tool is called Hathi, named after Colonel Hathi in the Jungle Book. It's one of the elephants, the grumpy one that boxes around Mowgli, if anyone remembers that movie. It's free and open source. It's MIT licensed. If you want to use it, create a private version. It supports Postgres, MySQL, and Microsoft SQL Server. And it comes with a custom password list that I put together. It's essentially a password spray tool designed for database infrastructure. You can give it a list of hosts that you want to scan. That can either be one server or an IP range. It will go through all the database and username pairs that it can come up with. And then once it's got a match, it will try the common passwords, and then it will try a custom password list. I've put together a password list of about 6,000 passwords that are database specific, but you can come up with your own as well, and I'll explain how that works. And then once it's finished and it's got a successful login, then it will report any successful credential pairs. To install this, you'll need Python 3.8, and you can install it using the pip tool. So pip install Hathi. And to run Hathi, you just type Hathi and then the host that you want to test or attack, depending on which way you want to look at it. If you know the username, you can give Hathi a bit of help by specifying the username. And if you have a custom password list, then you do -- passwords and give it a path to the password list. If you want more than one login credential, you can specify -- multiple, and it will look for as many username password matches as it can. Okay, so I'm going to give you a demo to show you this in action. Now, in terms of the tooling I used when putting this together, the first thing was an app called Wireshark. It's a sort of network analysis tool, and it essentially connects to Postgres and then analyze the actual packets that are coming backwards and forwards between the Postgres client and the Postgres server. This is where I noticed a few things. This is an invalid login. So I just typed in the username banana, and then I can't remember what the password was. It was something stupid. But Postgres gives you a lot of information back, even though I'm an unauthenticated user. So it tells me the error code, which is the 28P01 that I mentioned. It tells me the file that raised the error and the line number of the Postgres source code. This is funny because I can actually tell based on the line number which version of Postgres this is, even though it doesn't say in the error message. But I had a look on Git and it changed to line 335 in version 14. So I can now work out this is version 14. A Hathi tool itself works as a command line app. So I've got a Postgres server running on localhost, and it doesn't have TLS. So you use the no SSL flag. What Hathi will then do is it will see if it can connect a tool, and then it will sit and attack that server for me. So one thing noticed when putting this together is that the number of login attempts a second. So if this is running locally. This is running on a Docker image. Running this on production machines, it would run about 100 to 120 login attempts per second. So to put that in perspective, for 100, we're looking at getting through a password list of 6,000 in a minute. So yeah, this is a bit of a bit of a challenge. Postgres doesn't have any throttling built in. It doesn't have a retry count built in. So Hathi would actually quite happily sit there running through password lists of 60,000. And just over a couple of hours, it would sit there and just keep trying until it gets a successful login. In terms of what the Postgres user sees, they'd see a huge log file of invalid login attempts if people are monitoring the logs. So this one's found it's managed to successfully log in on the database Postgres, the username Postgres, and this terrible password of p@ssw0rd. If there's a couple of other things you can do, like I mentioned before, with Hathi, so you can specify at hostname if the server has the username at hostname as the username. You can also give it a custom username word list, custom password list, or you can also look for multiple credentials. Which is one additional thing. If you wanted to automate this, I've also added a --JSON flag, which will run the same tool, but it will output in JSON. So if you wanted to pipe this into some other sort of tool to do any audits or stuff like that, then you could do so. So that will give you whatever successful login pairs it could find for that endpoint. Yeah, in terms of the performance of this, it will run, I think, 10 parallel processes on the endpoint. So it runs basically 10 concurrent attempts to log in, and then pulls those to maximize the CPU usage on the machine to get through as many credentials as it can. There's a couple of other things I wanted to highlight in the presentation. One is the repository. So in the repository, so it's github.com/Tony Baloney, that's my username, /Hathi. And in there, there's the passwords.txt list. That's the password list that I came up with. But I'll show you, if that's too small, I'll show you some other ones that you can use, and also a tool that you can use to create a better list. So this is just a list of generated passwords based on words that I typed in, such as administrator, Postgres, Django, WordPress, website, and it would basically go and do substitutions as well as capitalize certain letters and append numbers and things which people are used to doing when they write passwords, is to stick an exclamation mark at the end or change the A with an @ sign, for example. So this basically turns that into a password list. You can also use, this is a sort of repository that's used by quite a lot of people called sec lists. This is used by security testers. And this is the URL. So it's Daniel Meissler checklist. And then in here, there's a password folder. And it's basically the most commonly used passwords, which are combined from different security leaks, but they've all been made public, ranging from top 10,000 to top 10 million. So you can actually go and run the top 10 million passwords if you want. And like I said before, Postgres will just keep replying. It doesn't throttle by default. It doesn't give a timeout by default. It will just keep letting you try and log in. The custom password tool that I use to generate this list, I link to in the repository. So what I recommend is if you want to give this a try, you use that list first, but then if you know the type of application that you want to test, at the bottom I've mentioned this one here, which is called Mentalist. It's a GUI app where you can give it a list of words, tell it how to create different types of passwords, and it will generate a password list for you. So that's the Mentalist app. So putting this together, then looked at, I guess, ways that we have Postgres infrastructure and also how our customers are using it. So what I'd suggest is that you look at testing your existing infrastructure using Hathi or using a different tool. You need to make sure that you don't have live infrastructure that has a username password pair, which could be predict guessed, and that your network security has been set up in the correct way. Also, the minimum password strength requirements are really important. But however, like I kind of showed in the password generator, if the password is password but with the A turned to an @ sign and the S is dollars, yes, that will meet password strength requirements, but it's still a bad password. So if you can educate people when they're configuring usernames and passwords, the best password is a 30 character random string. That's the best password you can come up with. Don't base it on the application name. Don't base it on a word. It should just be absolutely random. And if that was the case, then it would be almost impossible for this kind of tool to eventually crack. Also make sure that the configuration of host-based access control has been set up properly so that attackers can't connect in the first place. But keep in mind what I went through, which is that they will get a specific error back from Postgres. So really you should be using a firewall at the network stack, so at the layer 3 level, rather than relying on Postgres to do that kind of access control for you. With that in mind, the best model is to have a private network between your application and the database server. However, what I've actually seen in production environments is that people compromise the application server and then use that as a way to connect back into the database. So make sure that you've ticked basically all of the boxes above this, as well as doing the private network. And then if you do have a private network, the challenge becomes, how do we give access to our developers without just opening up the firewall? And that is where you need to really introduce a virtual private network to allow people to connect into the database. And then lastly, what we did in Azure, so we put this together and did a lot of testing in the Postgres services for Azure. We introduced rate limiting and throttling. So Azure Advanced Threat Protection for Postgres now will detect these types of attacks, and it will throttle them significantly. So you can only try and log in, I think it's once a minute, and then it basically just completely neutralizes this type of attack if you are running Postgres in Azure in one of the managed services. So yeah, thanks for coming to the event. It's been great to see something specific to Postgres, and thank you to everyone who helped set this up. If you want to keep in touch with me, my Twitter is Anthony PJ Shaw. My GitHub is Tony Baloney. The code for this is all up on there. And if you do have any questions, if they're on the chat, or ask in the Discord, or you can ping me on Twitter.
Thank you very much, Anthony. I think if anybody was sort of drifting off a bit there up here in the East Coast of the United States, that was sort of woken up by this point. We've got a couple of questions. Somebody's asking here, what is the suggested way to report Postgres vulnerabilities? And have you reported the overly informative auth error codes and line indicator in the libpq packet? Somebody's also mentioned here there is some context to that in the code itself, but it does raise the question about when is something a vulnerability and when is something, working as intended?
The right way to do it is to report it to the security mailing list. This is an information disclosure bug, but it's by design. So I only discovered this one, the line number this morning. But yeah, the subcode has been fixed. So in PG14 that has been fixed. The line and the source file, in my opinion, should be changed, but is the way it's designed. And I might submit a bug tomorrow. But yeah, that's public information, and it's designed that way. So it's not like I found a security hole. It's just more of a recommendation that you don't disclose that sort of information. But the right way is to go to the security mailing list, which is security@postgres.org, I think.
Somebody here.
Claire mentioned it on her talk.
Excellent. And yeah, and this also raises the question about, until some people actually see something like this, they may not think it's that important, or it may not find its way around the organization. So these kind of tools are very useful in raising we do need to do this. We do need to put it on a private network, etc. And I guess in managed platforms, we've got things like, actually we have managed identity, which we can use to connect, to our Postgres servers to avoid having to handle the passwords, etc. As often. So all of these, I guess, layered protections you laid out there. I know Hathi works with both Microsoft SQL Server and Postgres too. Somebody here is asking, how many brute force passwords can you try in MySQL per second?
I'm trying to remember which way around it was. MySQL is a lot still. I've got a screenshot of it on the in the repository. I think it was 80 a second I did with MySQL. Which is still a lot. To give you an idea, SSH is like 3 a minute or something. So by default, yeah, SSH will kick you out, and after like 3 failed attempts for a few minutes, and this is like 80 to 120 a second.
That's a lot, especially when people tend to choose passwords that are somewhat guessable in the busy developer world. Somebody here is also asking, they also wonder if there's a fail to ban rule that could guard PG logins. I guess that's something that could work for VM based.
Yeah, potentially. Yeah.
Excellent. And one other question, somebody also mentioned, so thank you for all the questions and feedback. You can use HashiCorp Vault to rotate the database password on both the apps and the database, even while it's running. So that's another, I guess, layered protection.
Yeah, that's an excellent suggestion. The place I guess I can see this being a big issue is if you've got a secure web, you've got multiple usernames in the database, and not all of them have strong passwords. So if you don't have any controls in place over all of the credentials, and you've set up a user or a reporting user, or there was like a developer that needed access and you just added, someone called Sarah and the password, web app 123 or something, then and it got forgotten about, then that's an issue. So yeah, definitely rotating the primary application passwords, but also making sure that you have some sort of controls over the other accounts as well.
Fantastic. And Robert Treat has just mentioned here, for anyone wondering, the best place to read about security reporting is postgresql.org/support/security. So if you're watching the live stream, thank you.
Thank you.
Well, thank you very much, Anthony. This was great. If anybody has additional questions, please feel free to drop by the Discord at aka.ms/open-source-discord. I'm sure we'll be around, and look forward to hearing more about this in the future. I'm going to run that against some databases sometime soon.